Welcome back, everybody. This is going to be part 2 of 5 in my lecture series on functions. If you haven't watched the first video, please go do that now. In this video, we're going to look at how to use function notation properly. Let's get started. Function notation is this thing on the right. We read this as f of x, where x is the independent variable. That's our input. We call y the dependent variable because its value depends on the value of x, which we choose independently. So this is our output variable. Now with functions, we can typically write our output as some rule surrounding our input. Now, drawn a beautiful little picture here. We can think about our function as machines, right? So maybe this particular function, f, is a blender. Now, blenders make smoothies. So here is our dependent variable. Y. Our dependent variable would be our smoothie. This is the output we get from the blender. Now, how do we get a smoothie? Well, we put in fruits or sometimes vegetables if you're a health nut, right? So we put in fruits. This would be our independent variable because we can choose whatever kind of fruit we want. Independent x. The function does some stuff to it. In this case, cuts them up and smoothens them out, and then spits out the dependent variable, y, right? So the blending happens and out comes the smoothie. Now we would have a problem if we tried to put a cat in the blender. We would not get a smoothie, we'd get a broken blender. So this is, and probably, at the very least, a misdemeanor charge. So in this analogy, I'm not bringing up blending a cat just because I think it's funny, but because it's part of an analogy that the domain of our functions are important to consider. Here, the domain would be fruits and vegetables or smoothie ingredients, right? So maybe dairy too can go in there. Right? And our range is the types of smoothies that we can produce with the fruits we have. So here we could produce strawberry or banana or strawberry banana smoothies, which sounds wonderful right now. So this is kind of a context that I think is helpful to look at functions in, especially when we get to using function notation. Now, I'm sure we've all seen problems like part A. Suppose f of x is x squared minus 4x plus 5. Find f of 2. Here is a super common mistake that I really don't want you guys to be making here. And I'm going to write it in giant red ink because it's bad. F of x is not f times x. F of x is not f times x. So, and now I'm going to promptly erase that because I don't even like seeing it on my screen. So, when I ask you to find f of 2, this is not f of x times 2. Otherwise, I would ask you to find f of x times 2. This is saying use 2 as an input in the rule defined by f. F is a rule that tells me when I get an x or an input, what do I do with it? I square it, subtract it by 4 times it, add 5 to it. So now I can use this rule given to me to write what happens to 2. Well, 2 gets squared. I multiply 2 by 4 and subtract it. And then I add 5. Here, notice that everywhere the x shows up, I'm replacing it with the input 2. And now I can simplify. This gets me 4 minus 8 plus 5, which is 1. This can get a little bit trickier as we see in part B. In part B, we're given the input 3 minus x. The same thing happens though. My input is 3 minus x. So everywhere I see an input in the rule, in this case it's just x, I write 3 minus x instead. So instead of squaring x, I'm squaring 3 minus x minus. Instead of multiplying 4 by x, I'm multiplying 4 by 3 minus x, my input, and then I'm adding the number 5. And now I've got some simplification to do. Foiling this out, distributing the minus 4, adding the 5, got a little bit more I can do here. First terms give me 9, outside negative 3x, inside negative 3x, last plus x squared. And now I need to combine my like terms. For my constants, I have 9 minus 12 plus 5, which is 2. For my x terms, I've got minus 3x plus 4x, which is 2x. And I just have x squared. So that would be the final answer. That said, see if you can use this on part C to find f of mushroom cloud. Go ahead and pause the video here and press play when you're ready. Again, nothing changes here. Our input is just a goofy little drawing of a mushroom cloud. I take it and I get mushroom cloud squared minus 4 mushroom cloud plus 5. That's going to wrap it up for this one. In this video, we learned how to use function notation. That's going to become really important over the rest of our class, especially in the next video, where we're going to talk about some other vocabulary regarding functions. Catch y'all in the next one.